This tunnel that you are seeing is not an ordinary tunnel, but it is literally the world's largest tunnel that passes under the sea. This 50-kilometer-long tunnel, which is 250 feet below the bottom of the sea, is the mega project that engineers call the seventh wonder of the world. The biggest reason for this is its construction. 13,000 workers working together in extremely difficult conditions and digging into the ground in such a way that the entire sea weighs on it. Even a small mistake can fill this tunnel with water and bury humans and machines forever. And that too, in just a few seconds. Welcome back to Info Nexus Videos. Viewers, when the last ice age was ending about 13,000 years ago, it had separated today's England and Europe from each other. Reason for their separation was this part of the sea, which is now called the English Channel. Although this channel is quite widespread, it becomes quite narrow at this point. And here, England and France are only 33 kilometers apart from each other. History has tried many times to end this distance, but these experiments were stopped after many deaths. Because maybe technology was very limited at that time. At the end of the 20th century, when technology was moving towards its peak, it was once again thought of connecting England and France with ground connections. This was the time of the 1980s when the biggest machinery was also possible. Another challenge, and that was to convince England. Yes, the cold water of the English Channel has always hit England hard on the enemies. From Napoleon to Hitler, many of England's enemies made plans to conquer it. But it was the harsh conditions of the English Channel that always kept England's back heavy. In World War I, Hitler also launched a secret project to dig an underwater tunnel from the village of Calais in France, so that England could be controlled, but this project could never start. After Hitler's death, business started booming and there was happiness everywhere. France and England, who were once enemies, started trading through the English Channel. Time passed, and in 1986, these two countries decided to remove this obstacle and connect England with Europe. There were a lot of protests against this decision in England because many people were very proud of this island kingdom of England. After many months of long talks, both countries finally agreed to make an undersea tunnel. It was named the Channel Tunnel, which is often referred to as the Eurotunnel. The agreement stipulated that the teams of England and France would dig a tunnel from their side, and both tunnels would come to the center point and connect. This project seemed like a huge failure even before it started. Making a 38 km long tunnel under the sea was not a task that a single engineering firm would dare to do. Finally, it was decided that 10 engineering firms would collaborate with each other to construct this project. Before designing the Channel Tunnel, it was necessary to know which transport would run in the tunnel and where it would start and where it would end. For mutual understanding, it was decided that a total of 3 tunnels would be built, in which a railway loop would run between England and France. One of its terminals would be called the City of France, while in England, the second terminal would be Folkestone. The total length of the tunnel would be 56 km, of which the part below the sea would be 38 km long. In 1986, the construction of the Channel Tunnel was finally started. The biggest problem that the engineering team had to face was the tunnel boring machine, also known as TBM. Because no such project had been made before, the TBM of this particular diameter was not available. First, this TBM machine had to be made from scratch. Thousands of miles away in Seattle, Washington, this special tunneling machine was commissioned by the Robins Company, who are experts in making boring machines. After completion, this giant machine would be 800 feet long and weigh 1,500 tons. Its diameter would be 50 feet, in front of which would be hundreds of sharp blades of tungsten carbide. The hydraulic legs attached to it would push it forward. A conveyor belt would be attached to the machine to remove the debris and broken stones, which would take the TBM to the service train, and then this train would take the TBM out of the tunnel. This tunnel boring machine was a miracle in itself. Compared to the old technique, in which the tunnel was made by blasting inside the mountains, this machine was a great blessing for the developers. But this new technology also brought a lot of dangers with it. If water leaks from somewhere 250 feet below the bottom of the sea during boring, its pressure will be so high that it will drown both humans and machines in seconds. The survey found that there is a layer of chalk under the sea on the English side, which will be able to prevent the leakage of water from entering the tunnel. But on the French side, there are a lot of cracks on the ground below the sea where this TBM will not be able to work. For this, a new TBM was decided to be made separately, which would be a submarine along with the tunnel boring. It would be able to tolerate the same pressure of water as the World War II submarines could. When this machine was ready, it brought a new challenge with it: how to deliver it 200 feet below the ground. For this work, the machine was disassembled and each piece was brought down separately. It had to be reassembled inside the ground, which took several months and millions of dollars. 2 years had passed since the project started. In 1988, the excavation work was finally started on both sides. Disposing off such a large quantity of mud and stones was also a very big task in itself. In one day, this machine was cutting 750 square feet of stones. And in just 1 hour, 2,400 tons of mud was accumulating. On the English side, this mud was put under the Shakespeare Cliff between Folkestone and Dover and made a country park called Sempire Hall. And that's why it's a little out of the coastal line. The mud collected from the French side was in the form of mud, which was put near Sengate in the Fon Pigeon Valley and made an artificial lake. On one side, so much mud was being pulled out of the tunnel, so on the other side, there was a lot of stuff to take inside. As the TBM was boring, it was also very important to seal the loose rock and chalk layer at the same speed. Because if the water above the sea makes way for the tunnel, it will be impossible to stop it. For this purpose, round concrete slabs of the size of the tunnel were being fitted. This concrete is stronger than the concrete used in nuclear plants. Approximately 750,000 concrete slabs made of reinforced steel were used in the Channel Tunnel. The weight of a whole ring of these slabs is equal to 40 tons, which means this is as much concrete as 8 Burj Khalifa-like buildings can be built from. They were put in a service train and taken to the tunnel, where there was a special machine that was fitting them in place. Many weeks passed and then months. The tunnel was slowly increasing on both sides. Everyone was waiting for just one thing, that when will these two tunnels meet each other? But this work, as easy as it seems to see and hear, was actually quite complicated. If both TMs do not move forward in the right position, then it is obvious that both tunnels will never meet each other under the sea. For the solution to this problem, a laser beam guidance system was being used. One laser was installed in an English machine and the other in a French machine. Both guidance systems were wirelessly connected to each other. Whenever a machine changed its position, the guidance system would send a signal to the main computer and change the position of the boring machine's head with the help of a hydraulic jack. With this, the two tunnels would align with each other again. Whether this guidance system was working properly or not, to confirm this, both machines would be shut down at the last 100 meters. And then a steel rod would be sent to the next site to confirm whether the position of both the tunnels is accurate or not. The position of both the tunnels was almost accurate, only there was a difference of 10 inches, which is within the allowed limit. Now the engineering team's biggest and toughest test. It was very important to make one of the two TBMs commit suicide. Yes, because there were 2 feet thick concrete slabs in both the tunnels. That is, the diameter of the tunnel was less than 50 feet and was now 46 feet. And the diameter of the TBM, that is, the boring machine, was 50 feet. When the work was over, the 50-foot machine could not come out of the 46-foot tunnel. That is why the solution to this problem was found that one of the two machines would have to be removed from the way, which is called mechanical suicide by engineers. So this sacrifice was made on the English TBM. Its angle was changed, and it was turned towards the ground, and after going down several hundred feet, it was left there, where it has been buried to date. Now the final moment of construction had come close. The French TBM went ahead and finally entered the England Tunnel, and when it reached here, the French TBM was disassembled and taken out. For the first time in 13,000 years, a land connection was going to be built between the two countries. For this event, all the workers who were working were selected from each country. They broke the last layer of chalk manually with a jackhammer and exchanged flags with each other for the media event. Thousands of years ago, after being separated due to glaciers, finally now England and France were reunited. It was really a great miracle that was celebrated to celebrate. The hard work of many years of blood, sweat, and tears had finally brought color. After completing the finishing work, on May 6, 1994, the Channel Tunnel was finally opened. If the cost of this project is adjusted in today's date, it will become £12 billion a 1,190 billion rupees. At the peak of construction, 13,000 workers worked in the Channel Tunnel, while 10 workers were killed in an accident while working. There are a total of 3 tunnels in this entire project. 2 for trains and a small tunnel has been built, which is used in emergencies. Today, about 60,000 passengers use this tunnel every day, which includes 4,600 trucks, 140 coaches and 7,300 cars, which are parked in the cargo train and the tunnel is crossed. I hope you will like and share this video of InfoNexus. See you in the next great video.